Here's what we're doing today. So I warned you yesterday that we're about to start the hardest stuff we've done all year. We're not gonna start the hard stuff till Monday. No, today is just some of the basics, nothing overly difficult. No homework, that is, unless we don't finish up the couple problems I want to. So remember how yesterday I promised you I'd only give you small homework assignments? Today's small homework assignment is completely capable of being completed in class. Last period had plenty of time to do it. If you guys don't get that far, then that technically that little bit will be for homework. I'll let you know when we get closer. So today we're just doing the introduction to the hard stuff. To begin with, we're going to be talking about seismic waves. It has been brought to my attention, we don't know what the word seismic means, which is fine. How about we talk about it? Does anybody know what they mean every time they say the word seismic? Nope, that's what I thought. So seismic waves are a fancy way of saying earthquake wave. So basically so seismologist, for example, is a person who studies earthquake waves. Seismic recording stations record earthquake waves. Seismic graphs are graphs of earthquake waves. So again, anytime you see something about seismic, it just is talking about earthquake waves. So it's not like a big fancy vocab word. It just means earthquakes. So what we're going to do today is, before we start into the hard stuff, you have to know what a P and what an S wave are. And I'll tell you, they're parts of earthquake waves. So what we're going to do is we're going to read the reading on page 17. Then on page 19 is where we're going to put the notes for this stuff. We're going to be getting the answers to page 19 from the reading. So what I want to start off with is highlighting answers. So I should have had to grab a highlighter. We'll distribute them right now. If you have your own, grab one. Otherwise, there's a highlighter coming around. So what do I mean? Yes, P waves and S waves are great names, but they actually stand for something else. Well, hang on, we're not there yet. So that's in the reading, what a P wave is and what an S wave is. When I ask for speed, I'm actually asking for two things, whether they're slow or fast, and then when they arrive at the seismic station, whether it's first, second, third, or 10th. Describe the movement. So in the reading, it tells you what the movement will look like. And a picture of the wave, we're going to do that part together. And type of matter. Do you guys remember what it means by type of matter? Yep, so I'm looking for solid, if I could spell. Solid, liquid, or gas for that answer. Or many or all of the above. So we're going to get all that information straight from the reading on page 17. Are you ready? Thanks, Mr. D. I'm going to grab some slinkies if I can find them.
Seismic waves. An earthquake is a natural rapid shaking of the lithosphere caused by the release of energy stored in rocks. Most earthquakes are caused by the movements of faults or faulting. During an earthquake, the potential energy stored in the rocks is given off as seismic waves or earthquake waves. Although earthquakes produce several different types of waves, we'll focus on two, P and S waves. Both waves are produced at the moment the earthquake occurs, but they have several different characteristics. It is important to understand the differences between these. All right, starting with P waves. P waves, or primary waves, travel as a region of compression. P waves are the fastest kind of seismic wave and arrives at seismic stations first. A longitudinal P wave has the ability to move through solid rock and fluid rock, like water, through the semi-liquid layers of the earth. It pushes and pulls the rock, it moves sound waves push and pull the air. Have you ever heard a big clap of thunder and heard the windows rattle at the same time? The windows rattle because the sound waves push and pull on the glass, much like P waves push and pull on the rock. Sometimes animals can hear the P waves in an earthquake, but usually humans only feel the bump of these waves.
So again, guys, for P waves, you're out there looking for their name, their speed, which all I'm looking for is, are they fast or slow? We're not there yet. And when they arrive at the seismic station, describe the motion. We'll do the picture part together and then type of matter they go through. So you should have just gone ahead and highlighted that information. You already fill it in, a couple of you. That's all right. We'll just make sure they're good at the end. All right, ready for S wave?
No.
Or you need a minute?
No.
All right, S wave is a little bit shorter, obviously, here. So S wave, or secondary waves, travel like vibrations in a bowl of jello, sorry. S waves are the second wave you feel in an earthquake. An S wave is slower than a P wave and only moves through solid rock. It arrives at the seismic station second, and this wave moves rocks in an up and down or side to side motion. So for the next few weeks, or a week and a half or so, this is the information you're just gonna have, it's just gonna have to come kind of naturally to you. You're freaking me out, Cadence. All right, something like these. All right. So this is just stuff you're gonna have to know. It's gonna, every time I say P wave, I want you thinking of the information we're writing down on this chart. Let's go ahead and see what you had to say. What, and I know I already heard this about a dozen times. What is the real name for a P wave? That's just a primary wave. What's their speed? Again, not looking for an actual miles per hour, but I was just looking for, yep, they are the fast ones. And because they are fast, when do they arrive? First, they arrive first. So when I say arrive, it means arrive at a seismic station. So that's just an earthquake recording station. A place with fancy equipment that can feel the ground shaking, even if it was tens of thousands of miles away. Describe the movement of the wave. What? That one wasn't side to side. That one was the push and pull. Now, that push and pull part, they tried to show it here. And honestly, the showing of it here is just about as good as I'm going to be able to do in person. But I will show you what this means in person. So we have this spring or like a slinky. And what the person is doing, and we're going to do this in live and in person here, but you can see they're moving their hand back and forth. So it's here first, then they move it here. And what you're going to be able to see is that when they pull it back out, it's going to stretch and compress. That's the push and pull. We're going to push and pull that slinky together and apart. So to draw that, I'm going to just try and copy this as best I can. I'm going to have some scrunched up parts of the slinky, followed by some spread apart spots, and then we're going to scrunch them back up together. Yeah, it's not award winning. And what type of matter did they say P waves can go through?
I'm thinking
Solid and fluid. I'm gonna go with solid and liquid. What? How can they? How can anything be?
We melt them.
Okay, remember, there are layers of the earth that are liquid rock. So when I'm talking about liquids, I'm not talking about water. I am talking about the liquid layers of the rocks. Oh, remember, the asthenosphere is partially melted, and the not the lithosphere, the outer core is also a liquid layer. All right, everybody, we ready to move on to S waves? Okey doke. What is
Secondary.
secondary?
Okay.
What's their speed?
So,
Slow, and when do they arrive at the seismic station?
second.
What motion did they say?
Down, side to side.
Okay, so I like to start with side.
Opportunity.
It's gonna have to be faster than Carter, huh?
Yeah,
Straight line.
falls.
So the S wave motion, again, we're gonna grab out a Slinky and try this. So what they're doing here is you're gonna be able to see, we're gonna move the Slinky up and down or side to side, and it will create this wave that to me looks like a couple of sideways S's. So just some up and down, your typical waves you see, but if you look at them sideways, I see an S. Okay. And then what?
Solids only.
Solids
Ah,
only.
ah,
Nope, I said solids only. You said
yeah,
solid rock.
it says solid rock.
And she's putting solids only.
Why is it annoying and distracting?
No. Not gonna say anything, you're gonna say something about.
We guilty conscience?
Next.
All right, before we move on to the next stuff, do you notice a common theme with the S waves?
No.
S is the common theme here. S waves, secondary, slow, second, side to side. This looks like an S, and they only go through solids. That's gonna be a really helpful reminder to you, because knowing that S waves only go through solids is the reason we know the inner core is a liquid. I don't mean the inner core, I meant the outer core. The only reason we know that the outer core is a liquid is because earthquake S waves don't go from one side of the earth to another. They get stuck in the liquid layer. So this is just a great introduction to P and S waves. No, stop. I'll let you know when we're done. So like I said, we're not going to really jump into the difficult stuff today. We're just doing a quick introduction. So now I need you to grab your reference table, page 11.
Already there.
The reference table is so confusing.
It is my goal to make it as not confusing as possible. So if you're confused, you're gonna need to make sure you speak up. The hardest part about the reference table is knowing like exactly where to look. All right, so you see this reference table on page 11.
You see that reference? Why is the S wave higher than the P wave?
So let's talk about that. Why is the S wave higher? What's the Y axis, which is controlling how high stuff is?
It's slow.
S wave is slower, so it's
Only
going
goes
to.
up and down. It doesn't.
Well, that's not why. So this
Right.
is, okay, so let's go back a step. Stop. Let's go back a step. What does this page 11 look like to you?
Graph.
It's just a graph.
Wow.
It's not a picture of the waves, so this is not what the waves look like. This is simply a graph. Yes, it's just a normal graph with an x-axis and a y-axis, a title. The only thing that makes it slightly confusing off the bat is that there's two lines, but they did a good job of labeling it. They labeled the P, they labeled the S. So to start with, this is not a confusing graph. It's just a graph like any other graph you've ever read in your entire life. We read graphs, we talked about reading graphs at the very beginning of this year. I always use this, well, I wrote my daughter's name instead of grade. I always use this make-believe graph here that has time studying in hours and grade, on the X, time on the X, grade on the Y. No, it is a completely made-up graph, because no, I know none of you are spending, up to 2 hours.
Oh, I am.
Studying. Oh, you are? Good, good. According to this graph, you're gonna end up doing well. So I'm gonna just make it up and say that it's gonna look like this. So if we were to basically read this, like back from the beginning, remember when there were no numbers?
Yeah.
Okay, so we did this in like September. If you remember, we read the x-axis, it's always increasing, because going from here to here is always increasing. Read the y-axis, describe what the line is doing. So if we do that, how do we sum up this graph?
More time you spend studying.
So as time increases, the more you study, your grade increases. So you know how to read the basics of graphs. The same is true here. The farther away from the epicenter you are, the time travel increases. Basics. But we're not gonna just be doing basics on this. We're gonna be flat out reading this graph a lot. So if we were to read this graph, and now let me put numbers back here. So half an hour, 1 hour, hour and a half, 2 hours. 50, 25, 75. According to this make-believe graph that I just put on the board, what grade would you get if you spent an hour studying? How do we do this? How do we read a graph? So again, wait, let me read my question again. So if you have 1 hour studying, what's your grade? Carter, walk us through it.
You go to the one on x-axis, you go on that.
Go to the one, draw a line. Do you officially need the line? No, but it definitely helps.
50.
Yeah, so it's not quite a straight line, but it's right around 50.
Oh.
So when you, and again, completely made up, if you spend an hour studying earth science, you're gonna do way better than getting a 50. But again, you go to the number you're looking for on the X, go up till you hit the line, read over. The same is true with this graph. So let's say, oh, I should go back. Do you remember what epicenter is? We did this yesterday. What's an epicenter? If you don't remember, we did this yesterday.
Back.
There you go. Look back in your notes from yesterday. What is it, Jeff?
Jeff?
Do you remember? Epicenter. So what's an epicenter?
Located on the circumference.
Yep, so it's really all it is where the earthquake happened on a map. So they're just asking how far away the epicenter is. So let's see if you can read this. Let me find a halfway decent one. Let's go to about this. If your distance to the epicenter was 1, how long does that take?
2.1.
Okay, so you go to what you do to get it.
I just drew a line up there.
So you started at 1, you go up, and you read over. You saw we were a little above the 2. You got it? Kinda. There was a couple things we want to talk about, because I left some stuff off of that example. Now, are you able to go the other way on my little make-believe graph here?
Yeah.
How long would you have to study to get a 100?
Right.
How'd you do that? Wait, not you two, somebody else. How?
2 hours up.
No, because that wasn't my question. My question was, how many hours would you have to study to get 100?
Take the 100,
Take
it
the
over,
100.
and then go down.
Go to the line, then go down. So we're a little above, or a little shorter than 2 hours. Again, make believe. Did everybody know how to read that graph that way? Okay, so we could do the same thing here. Before we do that, I think we better get to the nitty gritty things about this that I kind of left off the first example. Everybody, if you haven't already opened your own reference table to page 11, do it now. We're gonna add some helpful hints to it.
Do it now or you're gonna get rid of it.
Do it now or you're gonna forever be confused.
Do it now or you can't make it up for that long.
Today's Steve's birthday.
It is.
Alright. They keep, I'm just kidding, you're not here.
Okay, anyway, we've got the graph. Again, earthquake, P and S wave, travel time. Let's start with what the heck is a travel time?
How long it takes something to move.
How long it takes to travel somewhere. For example, in the morning, it takes me 45 minutes to travel to work.
Where do you live?
I live in Eden, so it's a pretty decent car ride, between 40 and 45, it
Why don't
depends
you work?
on the day. Because when I got a job, this is the job that was available. Why am I staying? Because I like the job.
Because you work for the pioneer.
That's it, especially you, Carter.
No, I'm not here.
Abso-freaking-lutely. Anyway,
Roger, Roger.
now that we're moving on from that, so travel time just means how long does it take from when you leave till you get somewhere? So now we're not talking about people, we're talking about P and S waves. How long it takes for them to leave the earthquake to get to wherever, whoever's feeling it. So that's what travel time means. So let's start with the x-axis, epicenter distance. We already said epicenter is where the earthquake is happening. This is just distance from where the plates are hitting each other. Now, I said originally 1, 2, 3, 4, 5, but if we look at the key here, is that one really talking about 1 kilometer? No, it's 1 times 10 to the third. What does times 10 to the third mean to you? We did this at the beginning of the year. Not 10 squared, 10 cubed, but
You move the decimal place to place.
it's scientific notation. Now remember, technically it does not just mean add 3 zeros. It means just like what Zach said, it means move the decimal point. So for example, if I had 4, it's, what do I do to find the actual, what this 4 means? I do times 10 to the third.
10 to the third.
So what do I gotta do? First of all, where is the decimal point in the number 4?
Yeah.
At the end, and by end you mean here. And so all I have to do is move the decimal point over 3 spots. Which way do I move it?
Right.
I move it to the right. Positive numbers go to the right, negative numbers go to the left. So 1, 2, 3. So plop it. That's not the decimal anymore. It goes here. Pop in the 3 zeros. That's 4,000. I want to add those 3 zeros to every single one of these numbers. So I want you to do this, but label them down like I just did there. So that's not 1, it's 1,000. It's not 2, it's 2,000. All the way to the end. And go down with these numbers, not across, because there won't be enough room if you go across. So we're not talking that you have to be right on top of the earthquake for a seismic recording station to feel them. You can be up to, according to this reference table, 10,000 kilometers away. They only labeled every 1,000 because if they labeled every single line, it would be so messy and overwhelming, you would get confused. But just because they didn't label them doesn't mean you don't have to pay attention to the other lines. So let's talk about what does each little line mean. If here's 0 and here's 1,000, not 250, not 0.2, because remember, they're going up from 0 to 1,000. So not 0.2, but not 20, 200. I would like to label one set of these lines. What do I mean by that? Right here, let's go ahead and label one set. So I'm gonna actually turn my paper so I can get it nice and neat in there. The first one is 200, 400, 600, 800, and the 1,000 is already labeled. So I know that's really small, you can barely see it, but I would like you to label one set. I don't want to go ahead and do all of them, it will get too messy. But if you label one set, then you know they all do the same thing. goes all the way up to 10,000 in that same pattern.
Alright.
Now let's look at the y-axis, the travel time. This was just given in minutes. Nothing fancy, no times 10 to the anything. So that's just 1 minute, 2 minutes, 3 minutes, all the way up to 24 minutes. But the same thing is true. What do the little lines equal? If here's 0 and here's 1 minute and we have 2 lines in between. Anybody have any idea what those little lines are going up by?
20.
20. How can it only go up to 20? That'll only get me to 60. Remember, there's only 60 seconds in a minute. So we're not going up from 0 to 100 or 0 to 10. We need to go from 0 to 60. So this first line is 20 seconds. The second line is 40 seconds. The 1 minute would be 60, which we don't say 60 seconds. That's 1 minute. So again, I did label one set. I'm not going to go ahead and label every single line because it'd be too messy. So now I know before we said that, I don't remember what number we did 1,000. Well, technically I only called it 1, but before I had you do 1,000. And we said it was just a little above the 2. Now can you be more accurate? How long does it take a P wave to travel 1,000 kilometers? Go ahead and try that. How long does it take the P wave to travel 1,000? So just like the studying, you go to the X to 1,000, you go up till you hit the line, and we go over. Are you all the way up to the 2 minute, 20 second line?
It's 15.
Yeah, I'd say it's a little below. So 2015 or 2000 or not 2000, 2 minutes and 15 seconds or 2 minutes and 18 seconds. But it is just a tiny bit below that 2 minute mark or 2 minute, 20 second mark. Do you think you can read this officially?
Yeah.
Okay, so the first thing I would have assigned for homework tonight, which we're gonna do right now, but not technically even homework, is on page 21. It says reading the P and S wave travel time chart on ESRT page 10. State how long it takes for the P and S waves to travel the distances listed below. I don't think we need to do this whole chart.
So,
Let's end after you do 4. 1, 2, 3, 4. So if you
what we
can,
gotta do?
it's not homework,
We're doing it in
it's
class.
doing it right now. So just up to the 1,600. So do 4 of them, which technically that means you're doing 8 because you gotta do the P and the S wave side.
8.
Does anybody want a ruler or a straight edge to help you out? Would this help? Yeah. Oh, you know what I have that might even help better? I think I do.
We're only on 1,600.
Yeah. Anybody want a bigger one? This helps a lot. These bigger ones are, I think this will really help. This really helps to be able to, like, what line are you actually looking at? Anybody else want a bigger one? Now, technically, you can't use this bigger one on the regions, but I think by the time we're done practicing, you'll be better off anyway. Let's do this first one. This is the same. We're going to we're going to 7,000 kilometers. How long do we think?
Shut up.
Yep. How do we figure out how long it takes? Let me get your ruler. That might help too. Anybody want a ruler, especially now that they got the bigger one? It might help you line up. So you're just using the ruler as a straight edge. I think it really will help.
Oh, I'm God.
No, give it
Can we do the given time now?
Yeah. Mhm. Now do the same thing for the S wave. You gotta still go.
Do they all have minutes?
All the way up. What?
Do they all have minutes and?
No, I think a couple of them are right dead smack on a minute one. Just check, double check your work to see if they're.
Are we only doing 4 for a given minute, or are we doing? For this one?
No, we're not there yet, but yeah.
Okay. Are we done now?
No, not yet. Where'd you get?
Only 4 of those. Points.
We'll check that one. That one. That's the correct one. If you're good to do the next 4. So since that one doesn't quite reach the maybe 56. And oh, I'm getting one from something. I'm wondering if you would speak out. Did I already check some of it?
So for things like this, things like whole numbers, either 0. You don't have to be that,
Okay.
you know, exact, which is fine. If you're like 1%, Japanese numbers,
Yeah, oh, where is
you
that?
want 5 or 0, make like.
Okay, thank you.
Yeah. That's the other one. You want that.
Okay, so there's 29. That'd be 38, yeah, so between 38 and 1,000. So now user will.
Other than that, once you go down to the
Oh, yeah.
same.
Yeah.
Yeah, we don't have to get over, okay, you're going to 4 of this.
Because there is.
You finish the other 4 of that?
Yeah, zeros.
4 on this one?
Yeah, on the next chart. That
Now we
is.
do this one.
Can you fill this out, guys?
Figure it out. Yeah. Which one? So now, the board, just like when I asked like what your grade was, if your grade was 100, how long would you have?
Well,
to study?
it's
Oh, so it's the same thing, now we know how long it is, we want to know how far.
That's 20, that's 40.
4 minutes, now we're 4:20.
Yep, that's yes.
4 minutes, I mean, 4 minutes is 20 seconds. No, that, you gotta go up the accent.
Oh, yes,
Remember that it was like 20? So that's 20 seconds, 4
I'm
minutes.
going like this, bro.
1 is this one. Which is? 4 minutes and 20.
I gotta be
So go to 4:20.
Yeah.
Follow the line over. Go, now follow that line down to be what I meant. Richard. Initial
Ah,
You still have some time now. Not much, but you know, and your numbers are. And then your homework.
oh, right.
Sure, get it on.
Now they give you the.
Yeah, it's not, it's funny, I just saw you. I don't think you see a lot of it, I think you see it. Oh, yeah. I think I got an experience in there, maybe your homework takes a lot.
Well, remember how I said if you don't finish?
Remember homework, Buster?
So 4 of them, 1. So there's.
Oh.
We're out.
You just check.
Sure, that's.
You're gonna do it anyway.
Perfect. Just do your homework. It's okay. Okay, so if you have not completed both charts, the top 4 of them, and I think I went around and talked to everybody. Tomorrow, on Monday, that's where I need you to be. I need you to have those 4 done. So remember how I said tiny homeworks, but I need you to do them, because I need to know you guys know how to do the easy stuff before we get to the hard stuff. That was the easy stuff. It's not terrifying, it'll be okay. If you, anybody realize that they would like a larger reference table, if you fold it in half, it fits perfectly into your actual reference table, just saying.
Listen, boogie to playlist improvement.
What the heck is a boogie?
It's artist.
Yeah, I'm gonna go with no, I haven't.